RAV4 here. I think it's about 2008. Customer complaint is starts fine when it's cold. Once it's warmed up, it refuses to start. Garage where it's at, it's replaced battery, starter motor, earth strap. Had it to an auto electrician apparently, who said there's nothing wrong with it electrically, so he's asked me to take a look at it. So I'm just the engine's cold now, so I'm just gonna get some data PIDs up. The cooling temperature, you can see it's 2 degrees, very cold. Current rail pressure, we'll have that. We'll have actually fuel temperature as well. We'll have that. We'll have intake. There seems to be a temperature related problem. We'll go for all the temperatures. Manifold absolute pressure. First time I've seen a Toyota that's read properly. That'll probably do actually. Go for engine speed. That's it. Air temperature. Right. So, let's see if this starts now. Just see, I haven't even tried to start it yet. So, it's like ignition off and back on again. Time for the glow plugs to go out. Started straight away there. Everything looks kind of normal. So I'm going to take it for a drive, get it warmed up, and then see what it looks like when it's hot. See you in a bit. Just doing it a short while there. I mean, literally about 2 or 3 miles. Starting to warm through there. But what I did notice when I was driving it, just stopped for a coffee. Might as well drink coffee while I'm doing this. What I did notice when I was driving it was it's very, it feels numb to drive. It's very slow at picking up. I've had the diagnostic tool sat on the seat next to us while I've been driving it. And the rail pressure concerns me. I don't think the rail pressure is rising fast enough, and I certainly don't think it's maxing out. So I think possibly this hot start issue may be something to do with rail pressure. So what I'm going to do is I'm just going to get rid of some other stuff. Leave that. So what I'm going to do is graph, do this over a longer period of time. I'm going to take it for a drive while graphing the rail pressure, because I don't really want to be videoing while I'm driving. But you should be able to get an idea of what I'm talking about when you see the graph. For some reason I wanted to record this. As you can see, these peaks here is me pressing my foot down hard. I mean, a peak there at about 120, something like that. Now at this point here, it felt like something let go and it went. So it went up to 130. It's still not as high as I was expecting. I'm sure these Denso systems run at something like 170 MPa, sorry. So I still think the fuel pressure is a bit low, but it definitely at that point there, it felt like something gave and it kind of went. But the events before with wide open throttle base, I was going downhill as well. I wasn't really putting on any load, but it was struggling to achieve maximum fuel pressure. I'm sure maximum fuel pressure on this system would be somewhere in the region of 170 MPa. I'm going to start to warm up there now, so I'm going to example. As you can see, the fuel pressure very slow at rising. Where it hit 133. So slow, that was me with my foot planted. Fuel pressure so slow at rising. I think it's going to be a fuel pressure issue. I was there just on that run back there. I was sort of took a step back and looked at the bigger picture there. I was looking at the manifold pressure at the same time. When I put my foot down, the boost in the rail pressure's not rising. Neither is the boost. The boost kind of slow to rise as well. So, is the rail pressure not rising a result of insufficient air coming into the engines? Because if the boost pressure is low, the airflow is going to be low. I'm more inclined to think the ECU would control fuel using input from airflow and boost, rather than control boost from input from fuel. So something to bear in mind is the car's still running at the minute. I'm just getting back to the garage, so I'm going to try and start it now. So I'm going to see what I can see when it's in a non-start situation. So switch this off. So that's it, switched off there now. Put the ignition back on to keep the data alive. So I'm going to then back to so I've got engine speed on screen, I've got common rail pressure, I've got mass airflow and manifold pressure on the screen. So let's go for a start. And it started up. Typical. Right, I'm going to knock it off for a little bit longer. So again, I've got the cooling temperature on there just to prove the engine is warm, 88 degrees. So let's go for it again. And it started. Fortunately, with faults, they've got to occur for me to find what's causing them. And this one seems to be occurring, or not occurring, should I say? It's starting up. So I don't know what to suggest here to the customer, but it's like, kind of like calling him a liar, but I'm sure he isn't. Yes. We'll try again. There. Non-stop there, fuel pressure's up there. Alright. There we go, fault proved. Get some more data PIDs on here. Let's try again. Thanks there for the stars. Kind of a weird cadence with the engine there. Maybe worth investigating that. Chat with the garage that the car's at, and because I noticed it's got what looks to be like a very relatively new turbo on it, but when you drive it's got a bit of whine on the turbo. Like I kind of dismissed that at first, but now I'm looking, it's got a new turbo and it's got this turbo whine. I'm kind of thinking, is this something to do with it? So I think I'm going to pull this intake off and check this turbo. So there's no history on what's gone wrong with this car. Took the intake pipe off this turbo. Just stuck my fingers in, and the turbo is absolutely knackered. It's got loads of end flow on it. You're not going to be able to see anything, but right. Get in there, hang on. Oh, it looks like it's eating something. Oh. Flash on hard to see there, but I think the starting problem is going to be at least of this guy's problems. So that turbo is absolutely wrecked. It looks like something's been through it. So I think I better advise him on that before we go any further with the starting problem. This could be one and the same problem. Right, conclusion of this one, just bought the garage. They're going to get a turbo fitted and they're going to take it from there, see if it improves its hot start. It may have something to do with the turbo, may not, but in the day it needs a turbo one way or the other, so it's going to get one. If it continues to not start, I'm sure we'll get a phone call, come and have a look at it once it's got a new turbo fitted. We'll see how it goes. Thanks for watching. I took another look at the video I took of the live data on screen when this car wasn't starting, and I've now come to the conclusion that this turbo has actually been the cause of the non-starts. If you notice, when it's in a non-start situation, the airflow is below 5 grams per second, but when it does start, the airflow goes above 5 grams per second. The only explanation I can give for this is the fueling is calculated from airflow. It's using the flow of air into the engine to calculate the amount of fuel it's injecting. So if the airflow is low, the amount of fuel that's injected is low, thus you end up with the poor starting. This doesn't affect it on cold starts because there will be a cold start strategy in the ECU, so it'll kind of override the airflow input. Anyway, thanks for watching. If I